Here is an example of a liaison proof. Remember, there are 3 major steps to any liaison. The first is to prove that the line in question is the perpendicular bisector of a segment. The second step is to prove that the point in question is equidistant from the endpoints of that segment. And then the third is to state that the point lies on the perpendicular bisector. So I'm going to start this one, of course, by reading the givens and marking my picture. So angle 3 is congruent to angle 4. Angle 7 is congruent to angle 8. As I'm marking these, I'm now realizing I can get triangle ADE congruent to triangle CDE by angle side angle. That seems like it might be really helpful. I also have that angle 1 is congruent to angle 6. So I'm noticing from my congruent triangles, I could get 2 and 5 congruent by CPCTC. Using the addition property, angle BAE congruent to angle BCE, which then of course implies that the opposite sides are congruent, and that's how I'm going to get B equidistant. Now that's great, but have I actually proved that ED is the perpendicular bisector? And again, through some additional CPCTC, I think I can find 2 points equidistant from the endpoints A and C. And of course, if 2 points are equidistant from the endpoints, they form the perpendicular bisector. So I think this is going to be a good one. Starting with angle 3 congruent to angle 4 and angle 7 congruent to angle 8. I'm going to include the reflexive property. DE is congruent to itself by the reflexive property. And this is enough for triangle ADE to be congruent to triangle CDE by angle side angle from steps 1, 3, and 2. I think we're going to have a lot of CPCTC happening now. So I think I'll start with proving that ED is the perpendicular bisector. So I need 2 points equidistant from the endpoints. I can get E equidistant by stating that AE is congruent to CE by CPCTC. Similarly, AD is congruent to DC by CPCTC. So step 5 shows that E is equidistant from A and C. Step 6 shows that D is equidistant from A and C, which means that ED is the perpendicular bisector of AC because 2 points equidistant from the endpoints of a segment determine the perpendicular bisector. And that right there is SP1, strict procedure step 1. So now the second part is to prove that B is equidistant from the endpoints A and C as well. So I'm going to go back and state that angle 2 is congruent to angle 5 because corresponding parts of congruent triangles are congruent. And then use my final given. Angle 1 is congruent to angle 6. Together, those 2 steps allow me to state that angle BAC is congruent to angle BCA by the addition property. And then that implies that the sides opposite those angles, so BC and AB, will be congruent. Given those congruent angles, the sides opposite them are congruent. And there's strict procedure step number 2. The point in question, B, is equidistant from the endpoints A and C. So now, finally, I can state that B lies on ray ED, because if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector.